this is the actual hydrodynamic flight simulator that we were just looking at graphically on the screen. This will be our attitude indicator. It's just for fun. I'll point out the various components and we'll go flying. And we don't have a whole lot of time, but I'll stay as long as you'd like to stay. First thing that we're going to do, as we do in any airplane, is we're going to turn on our systems and we're going to do a system check. That power supply powers a low kinetic energy warning. You could call it a stall indicator. If you can see, there's a little light over here. It also powers a solenoid. The solenoid we were talking about earlier will dump altitude from this altimeter when we're stalling, when the wing isn't producing any energy at all. I'll set my Spirit of St. Louis over here. Here is our potential energy reservoir, fuel if you'd like, our energy flow control or throttle. This is our control stick. Haven't flown it for a while, so let's see how we do. This is our control stick, and before we take off, we want to make sure that our controls work smoothly. Remember, this is our airspeed indicator. This is our low kinetic energy indicator or stall indicator. It's a micro switch with a float at the end, and at a certain point, it won't be floating anymore. It's going to open that solenoid switch and dump all of our altitude. There's also a valve, I don't know if you can see it here, with a cam, and as the stick is pulled back, the cam pushes down a valve that dumps airspeed, because as we increase the angle of attack, we're getting more resistance over the wing, and our airspeed is dropping precipitously. So again, if anyone has any questions, feel free to jump in. We're going to take off. We can take off, climb, cruise, stall, and land. I'm not sure if we're going to have time to do all of that today, but let's give it a shot. There's our throttle, and I'm opening the throttle. Actually, it operates a little bit backwards. I pull towards me. If you can see the red liquid, hopefully you can see the red liquid in the airspeed indicator, and we're reading it in knots, and we're up to 140 knots. And you may have noticed that our low energy warning light went off, which means I have enough airspeed to climb. I'm going to pull back on the stick, and if everything is working correctly, I'm going to be converting some of my airspeed into altitude. Maybe I should have put more food coloring in. I'm not sure. And this is not a jet airplane. It's maybe more like a Piper Cub, but we're climbing at about 80, 100 knots, and we're coming up on, this is feet in altitude, 400 feet, something like that. So we just have to be patient while we're climbing. If we climb at a higher angle, we're going to open this valve here a little bit more, which will bleed off some of our airspeed. So we don't want to be climbing too steeply. We could fly faster, but we wouldn't gain as much. We wouldn't gain altitude as quickly. So what's going on here? There is a myriad of holes along the vertical axis. The faster that we go, the more resistance we encounter. That's on the airspeed side. On the kinetic energy side, oops, we're going a little bit fast. So we were going kind of fast, but we weren't picking up as much altitude as we would like. So that the myriad of holes is bleeding off energy, and that's all being dumped into a tub over here. Some of our energy is being converted into altitude. This is our altitude. But as we go higher in altitude, the air becomes less dense and our airplane becomes less efficient, and we'll lose more of that potential energy because the plane is at a higher altitude and it's less efficient. I thought I would climb a little bit faster. Let's see what happens when I stall. I'm going to stall, and I don't know if you guys can see this light here, but that's our low potential, that's our low kinetic energy warning light. And what that's going to do, that opens a solenoid valve here and it dumps this altitude. And you'll see this altitude drop kind of precipitously. And you wouldn't want it to get down to zero because that means you hit the ground and you crashed. So you want to push the stick forward. And you know, if you've flown or if you've taken flying lessons, you know that one of the things that you want to do when you stall is relax the pressure on the stick, get the airspeed up, which we just did over here. Hopefully you guys can see the food coloring in the water. And now I'm pulling back, so I've got my airspeed way up. I didn't hit the ground, thankfully. And now pulling back on the stick to get back to a flying attitude and to put to get my altitude back again. So what if we wanted to land? We're at about 800 feet. So let's say we wanted to land. Maybe we want to do a dead stick landing. Might be fun. Dead stick landing, no throttle, which means I've got to keep my airspeed up. I've got to drop the nose of my plane. And remember that low kinetic energy warning. So now the altitude, the potential energy, is being converted into kinetic energy, airspeed, so that my plane is still flying, right? It's still flying. My little low kinetic energy light hasn't come on yet. We're down to 400 feet. We're down to 200 feet. We're still flying. We're getting closer to the ground. We still have enough airspeed to fly. We're getting closer, closer, closer. And that was our stall indicator. Pull all the way back on the stick to bleed off any remaining energy. As I said, I haven't flown it in a while. And now we're back down. Hopefully, hopefully we're back down on the ground. So that's, in a nutshell, the hydrodynamic flight simulator.